has a direction.
Vector has a direction. Okay? So when we talk about a vector and a scalar quantity, a vector quantity has a magnitude, right? A units, and also has a direction. Whereas a scalar has your magnitude and your units, but no direction. Okay? Now, that becomes important to us when we start talking about velocity, displacement, speed, and distance. Okay? For the most part, we are going to focus our study on vector quantities. Direction is going to be important to us. So what I'm going to do right now is I'm going to show you the difference between the two and a simple math problem that goes with this. So actually, before I get going, I should talk about this too, about what is physics. Because you take in grade 10 physics as part of that grade 10 science. This is a very math-oriented course. So if you have struggles in math, you may see some problems doing this. There is a lot of problem solving here. We don't do as much theory. We do more theory in grade 12 than what we do in grade 11. But the grade 12 course, like the grade 11 course, has a lot of math in it. So if you are having difficulties with math, this may not be the option for you. So you've got to ask questions, you've got to get help, and look for solutions either from myself or somebody that's sitting beside you. Okay? So we got vector and scalar. So here's a start. Here's an idea of a question, and it simply goes like this. If I go from Rollin to Yorkton, and it is 79 kilometers. Okay? So I go from Rollin to Yorkton at 79 kilometers. What is the distance that I traveled? 79 kilometers. That was easy enough, right? What's the displacement?
79 kilometers unless you come back.
No. What's the displacement? If I go from Rollin to Yorkton?
Negative 79.
It could be, but we're not. Be more specific. We know the
79 kilometers west.
79 kilometers to the west. Okay, we're going to consider this west over here and this east over here, right? Okay? And just the same on your nautical directions. North, east, south, west.
Mary Ferguson to the office.
Right?
Mary Ferguson.
So we consider west, left, east, right when I draw pictures. Okay? So the difference between the displacement, which I'm going to make as delta D, and my distance, which is just D, the displacement is 79 kilometers to the west. The distance is 79 kilometers. Okay? Displacement is a vector quantity in which we have to put the direction on it. Okay? So now, if I go from Roblin to Yorkton and back to Roblin, what's my distance? 158. 158 kilometers. Good job, man. Okay, 158 kilometers. What is my displacement?
0 because you're back in the same
0. Because displacement is my final position minus my initial position. So if your final position is exactly where you started, then you've got 0 displacement. All right? Now I go from Rollin to Yorkton, and then I pass Rollin, I'm going to make a delivery to Grandview. Well, Grandview is 53 kilometers away in the east direction. So now I'm currently sitting in Grandview. What is my displacement?
53 kilometers east.
53 kilometers to the east. What's my distance traveled?
211 kilometers.
211 kilometers. I just add it all together. Distance, you're just adding everything together. Displacement, you take your final position minus your initial position. Okay, so far? All right. And this again, that's all stuff that we should have learned in grade 10. All right, so now here, I'm going to introduce one more thing. Okay. I go from Roblin to Yorkton, 79 kilometers, and I travel 100 kilometers per hour. Okay? So I'm going to say my speed is 100 kilometers per hour, and my velocity is 100 kilometers per hour. Does that look right to you? Should my speed and my velocity be the same thing?
No.
Why not?
Velocity has direction.
Velocity has direction. You're right. The magnitude's the same. The units are the same. But I have to add a direction if I'm going to do this properly. So, which direction was I going to go from Roblin to Yorkton?
West.
I was going west, right? So 100 kilometers an hour to the west. Okay? So now, how long did it take me to go from Roblin to Yorkton? How long did it take me to go from Roblin to Yorkton? 48 minutes. How do I get 48 minutes?
You take the 79 kilometers an hour and you divide it by 160.
Okay, so let's do this. You went way above and beyond here. So I've got distance over time. Oh, sorry. That's distance over speed. There it is. Distance over velocity is equal to time, 79 kilometers. And actually, this should be speed, not time. Do it this way first. And that's 100 kilometers an hour. So it takes 79 divided by 100, which would give me how many hours that is. And then Emily converted it by multiplying by 60 minutes, right? And she got 48 minutes. But that's a little bit beyond. So for right now, just give it to me in hours. 79, so what is that, 0.79 of an hour? Okay? And actually, this is a good time to go through that. I have 0.79 hours. How do I convert 0.79 hours to minutes?
Multiply by 60.
Okay? What is the ratio of minutes to hours?
60 minutes to 1 hour.
So I'm going to write this out like this. I want minutes on top, and I want to get rid of hours on the bottom. Okay? So that divided by that gives me units left of minutes. 0.79 times 60 is approximately 48 minutes. Okay? We'll go through conversions as we go. So grade 11s, this is for you. These grade 12s have done all of this already. Okay? So for you, if you're finding that you're not sure, you don't understand something, you're going to have to ask frequently. We'll slow it down because I got to go through this fairly quickly because this is part of the 11 course. But in order to get to the 12, we want to have this part of the 11 course. Fair enough? So don't be shy. Ask questions. Okay. So going back to my original. So here's Yorkton, Roblin, Grandview, 79 kilometers here, 53 kilometers here. Okay. I want to know the time to go from Roblin to Yorkton back to Roblin. How do I find the time? What is time equal to?
Distance over velocity.
No. Distance over speed. It's one way to do it. Or displacement over velocity. Correct? So depending on what you're looking for, those values should still be the same. But what's the difference? One always has direction, right? Okay? But time is not considered a vector quantity, so you don't need a direction on it. So in this sense, you want to just find out what it is. However, if I was looking for the velocity that I traveled, that is a different story. So here's how it works. It takes me 2 hours to go from Roblin to Yorkton, back to Roblin. What was my average speed?
100 kilometers an hour. So do
Speed equals what? Did I go 100 kilometers an hour?
79,
79 what?
because it took me 2 hours to go 75 kilometers an hour.
Okay, so explain to me how I solve it then. How do I find speed?
Distance over time.
It was under GLHI too, it wasn't under mine.
Keeps coming up as Brant.
Then I checked to see what it was under, it had GLHI too, unless we have to reset it, I don't know.
I don't know, but it keeps coming up under your name, because I would have put the iTunes one in, I know the iTunes password. Okay, so I'll check it again, if it happens again, I'll leave it up, and then I'll come get you. Okay, so how do I find speed again, sorry?
Distance over time.
Distance over time, well, how far did I go?
158.
158 kilometers, in how long?
2 hours.
2 hours. So what was my average speed? 79 kilometers per hour. What's my average velocity?
Zero.
Yes, it was. Yes, it was. My average velocity? 0. Because how do I find out what velocity is?
Displacement over time.
Displacement over time.
So that's
So if I went and started in the same position, what's my displacement?
zero.
It's 0.
So it's like how far you ended up from where you started.
That's right. That's right. So let's do this. Okay? It took me 3 hours because I had a little stop at McDonald's in Yorkton, then I had to stop in town. It took me 3 hours to go from Roblin to Yorkton to Grandview. What was my average speed? I went from Roblin to Yorkton, back through Roblin to Grandview. What was my average speed?
70.3 feet, 8 kilometers an hour.
How'd you get that, Marshall?
Distance divided by time.
And how far did I go?
211 kilometers.
211 kilometers and 3 hours, right? 211 kilometers in 3 hours. So what was my average speed? 70.3 kilometers per hour. Is that what you said?
Yeah.
Good. Good. What was my average velocity? That's not velocity, is it? What is that? What was my average velocity? 53.
Kilometers an hour east.
Very good. We gotta put all that in there. 53 kilometers per hour east. Right? And how long did I do that in? 3 hours. 53 divided by 3,
17.63.
17.67 we'll put kilometers per hour. And east. Now I didn't travel east for the entire time. Did I? Went west first and then came back to the east, but ended up east of where I started. Right? So my final position minus my initial position is my displacement. That's how I get displacement. So when you're doing any question and it asks you for average velocity, you find your displacement at the very end and divide it by your total amount of time. Okay? It's going to be important to you that you understand this because we're going to get a little more complicated as we go here, and we want to understand that. So, let's go to Okay, so the next order of business. I'm trying to just get enough information here that I can do this without having to go through the whole unit with you, because you're gonna do the whole unit next year. So, turn to page 49 for a second, please. Now, we're not gonna do much with graphing, but I need graphing to explain some equations to you. So, here's how this works, all right? We have already talked about this. Change in velocity is change in displacement over change in time. Everybody agrees? 50 over 2, awesome. All right, if I take a graph and I go, this is my y and this is my x. And I want to find the slope of that line. Okay? I want to find the slope of that line. How do I find the slope of that line? What's my slope?
X over Y.
Marshall?
Oh, no, Y over X. Sorry. It's been a long summer. I haven't had to think in like 3 months.
Going on 16 years? Okay, here's what it is. I'm like Marshall. Your slope. Change this. Your slope of any line is change in y over change in x, right? Rise over run? y2 minus y1 over x2 minus x1. We all agree? Okay, here's what I want you to see. I'm going to do a displacement time graph in which my displacement is y and my time is x. So if that's the case, that means that this becomes delta d over delta t. We agree? And what does delta t over delta t give me? Gives me velocity, doesn't it? Right? So if that gives me velocity, then what I'm saying to you is if I take the slope of any line on a dt graph, by taking the slope of it, what am I getting? I'm getting my velocity from it. Agree? So let's look at A right now. We're going to look at section A. So to find it, I need x1, y1, and x2, y2. So for A, section A, what's my x1, y1? Where do I start at?
0 and 0.
0 and 0. And where does A end at?
2 and 6.
2 and 6. So knowing that, can I find my velocity for that section?
Yeah.
Yeah, I can. All right, so how do I do it? y2 minus y1 over x2 minus x1, 3 meters per second. That's my slope in A. Do we agree? Units are right? Meters and seconds? Yeah? Okay. What about B? What's my velocity in B?
0.
How come?
Because it's just a straight line.
Just a straight line.
Time's passing, but you're not getting any more distance.
Very well said. Is my distance changing in B? Does my distance change? No. Is time going on? Yes. So that means then I'm not moving, correct? So my velocity in that section is this. Okay, how about C? What's x1, y1, and C?
6 and 6.
6 and 6? What's my x2, y2? Pardon me?
10 and negative 10.
10 and
Negative
negative 10. All right. So now, to find my change in velocity in that, what's my change in velocity here? y2 minus y1 over x2 minus x1. What does it give me? minus 16 over 4, which is minus 4 meters per second. What does the negative mean?
You're going backwards.
Going backwards?
The opposite way that you were going to begin with.
I am going in the opposite direction that I was going before. On a DT graph, if your velocity is a negative, it means you're going in the opposite direction that you were before. It doesn't mean you're slowing down. It doesn't mean you're slowing down, it means you're going in the opposite direction. Everybody follow so far? What's happening in D now? Not moving, am I? Right? Time's going, but the distance isn't changing. The displacement isn't changing. Agreed? E? What about E? What's my x1, y1?
12 negative 10.
12, negative 10. And my x2, y2?
13 negative 6. Maybe.
Close enough, I guess. Okay, I don't know what it is. Change of velocity equals minus 6, subtract negative 10, over 13 subtract 12, which is equal to
4 over 1.
4 over 1 meters per second. So now, what does that tell me about my direction?
You're going back to where you started.
Going back to where I started, right? Okay so far? Again, I'm cramming this on you. But all right. Any questions so far? Okay? It's hot in here too, right? All right. Go to page 61. 60. Sorry? Page 60. Who knows what acceleration is? Guys drive those trucks all around town, squealing your tires, trying to create acceleration. What is acceleration? For me?
Speeding up.
Speeding up? So what's...
Change of velocity.
Yeah, very good, guys. Okay, that's what it is. How fast are you changing your speed? That's what it is. It's called the rate of change. So acceleration, theoretically speaking, is your change in velocity over the amount of time. Okay? For those of you in grade 12, what are your SI units for velocity?
Kilometers an hour a second.
No. I asked you meters per second.
Come on, Marshall. Or-
Told you, it's been a while.
Okay. Grade 10, or grade 11s, I'm gonna call you grade 10, but grade 11s. Do you guys remember what SI units are? You remember? Okay, so for distance, what's your SI unit? Nope. Okay, so let's do this again. I'm gonna go back. This way, distance, velocity, time, mass. I don't need velocity. Okay. What do we measure distance in for SI units? In physics, what do we do? Meters, right? Meters. And then everything is a prefix before that. Kilometers, centimeters, millimeters, whatever. So that's our standard SI unit. What do we measure time in when it comes to physics? Seconds. Okay? And what do we measure mass in when it comes to units? Kilograms. Kilograms. Okay? kg. Okay, so I'm just putting that out there. Grade 11s, I'm going to give you a bit of a homework assignment tonight, just so that you get familiar with that again, and that'll be earlier on in the textbook. Okay, so the grade 12s, you probably should look at it too, Marshall. Okay. So, we got meters per second, which actually gives me my units for acceleration. My units for acceleration are meters per second squared. Okay, and the one that we should know at all times is the Acceleration of gravity. What's the acceleration of gravity?
Negative 5.8 meters per second.
Negative.
Isn't it? Is it? No. Because it's
No.
going down.
That means
How do you know I'm going down?
Because gravity pulls you down.
So then you're increasing your speed as you fall.
Yeah,
So is that a negative value or a positive value?
your direction's negative.
you can't say the case.
We'll revisit that case. Okay, so right now, meters per second squared. Gravity, we will talk about it. Yes, the direction meaning down, usually we make negative. But when we speed, but we're speeding up as we move down, so I make it positive. But anyways, that's for a whole different day. Okay, so acceleration. So now, acceleration is the change in velocity over the change in time. So what happens if I do this again? This, here, and now I make that velocity and that time instead of x and y, instead of displacement and time. What does that mean for the slope of this line then? It's what, sorry?
If there's acceleration, like,
Okay, it can be, yes. So let me come back to that for 1 second. For right now, here's what I'm asking you. What is my slope equal? Okay, but in this graph I don't have y and x. It's what?
Total velocity over total time.
Change in velocity, not totals, over change in time, which ends up being a total. Okay, so change in velocity over change in time. What did we just say change in velocity over change in time is? It's acceleration. It's acceleration. So from a VT graph, we can get the acceleration. Now, come back to what Emily said. Acceleration, much the same as velocity, may not always change constantly at a constant rate, excuse me. So, if it doesn't, it may have a curve to it. So you start thinking about a vehicle then. It's going to start slow and then it's going to accelerate when you hit it. Or it's just going to be at a standstill because you're spinning your tires. So it goes like that. So what happens here? Well, what I do, and again, I don't need you to know this year. Okay? But what I do here is I actually take the spot where I want the acceleration and I'm just going to divide it by whatever the velocity is here by the time right here. Now in the textbook they're going to say, well, you got to find the tangent there and then find the slope of the tangent. Well, who knows what a tangent is? What's a tangent? On a graph, what is a tangent?
Opposite over adjacent.
You're just full of it today, aren't you? Okay? So a tangent on a graph is drawn on a curve that touches at one point and is actually perpendicular to the radius. So long and short of it means this. I just draw a straight line right here that touches at that point on it, and then they say find this coordinate, and then find the slope of it. I don't need you to do that. Just take the velocity over time at that point. That's instantaneous acceleration as far as I'm concerned. Instantaneous meaning at that instant, right now, what's the acceleration? Take your velocity and divide it by your time. Okay? So, we don't need it for a curve. Again, I don't need it. All of this, what I'm trying to do right now, is show you something else. I'm getting into some equations that are necessary for you in order to do this. Okay? Second of all, before I go any further, the grade 11 course, all right? If you talk to anybody that's taking the 11 and 12, they're going to tell you that 100% they like the 12 course better. Okay? So stick with this as long as you can. Because if it's confusing now, it will get better. But right now, it's going to take some because those of you that didn't do this last year, we're going fast, it's overwhelming. Just slow it down, ask questions when you need. And grade 12s are in here. From here on in, there will be no more 12, 12, 12, 12, 11, 11. You're going to pair up with 12s and 11s. That way, everybody gets on the same page much faster. Okay, so we're going to branch out. After today, you sit by somebody that's not in your grade. That way, things will go better for both of us. Okay? So back to this here, acceleration, velocity over time. Now, I want to look at page 69. 96, where I'm standing. Okay, so 69. So I'm gonna look at this graph right here. I just finished telling you that the acceleration can be found by taking the slope of a line on a VT graph, right? So here's how it looks. That graph looks like this, and then comes all the way back down, and I don't care after that point right there. So the first thing I want you to do is I want you to find out what my acceleration is at that point. Now I put an arrow on top of that acceleration, that variable. What does the arrow mean? It means I need direction. It means it's a vector quantity. Acceleration is a vector quantity. So in the case of doing it on a graph, a plus and a minus is direction. Unless you say, okay, well this is east and this is west, or this is north and this is south, as long as this and this is fine by me. Plus and a minus. Okay, plus means you're moving in a certain direction. Minus means you're moving the opposite direction that you were originally moving in, or whatever. Okay, so here's how this works. I want the acceleration. So what's my x1 and y1? 0 and 0. What's my x2, y2?
15 and 2.
15 and 2?
2 and 15.
Which one is it?
2 and 15.
2 seconds I go, big difference, right? We can't mess that up. 2 seconds I go 15 meters per second, that's all right? Okay, so now, what is my acceleration?
7.
15 minus 0 over 2 minus 0, which is equal to 7.5 meters per second squared, right? All right. So far, so good? So that right here is 15. That's what you're telling me? This is 15 right here?
Yeah.
Beauty. What's the acceleration in part B?
0.
0. Does it mean I'm parked?
Because you're going the same speed. You're not accelerating or decelerating.
So I'm going the same speed?
Yeah.
So am I still moving?
Yeah.
You sure I'm not stopped?
Because it's measuring your acceleration, which is the change in velocity, so you're going at constant velocity. And if it was
Yes.
straight at the 0,
Yeah.
then you would be stopped.
Very good. Very good. How fast am I moving right now?
15 meters per second.
15 meters per second. We all agree? Looking at that, 15 meters per second? Awesome. How long did I go 15 meters per second for?
3 seconds.
Yeah.
3 seconds. So you're telling me that I went a velocity of 15 meters per second for a time of 3 seconds.
Yeah.
What's my acceleration?
0.
How far did I go?
45 meters.
Where'd you get that?
Velocity times time.
Velocity times time. My displacement is found by taking velocity times time. We agree? And right now, I am moving at 15 meters per second for 3 seconds. So how far did I go?
Wouldn't you have to add your part A to that as well?
Not there yet. Just wait. You're ahead of yourself. How far did I go? 15 meters per second for 3 seconds. I went 45 meters. How far did I go in part A?
15 meters,
I did 15 meters.
because you went 7.5 meters per second for 2 seconds.
7.5. So you converted that to, how did you get that?
Your average velocity for part A was 7.5 meters per second, and then you times it by how far you went, or like how long you went in part A, so by 2, so 15 meters.
Okay. I think you got the answer, but I think you got it in a roundabout way. Okay? It's not, you're right, I think. I'm gonna have to do it in my head here. But here's the thing. When I look at a graph right now, in order to get my displacement, I'm going to find the area underneath here. Because that's what I did right here. I found the area underneath here. This area right here worked out to 45 meters. So if I find the area of this part, it should give it to me. So, what's this shape? How do I find the area of a triangle? Half base times height. Half of my base, which is 2, times my height, which is 15. So half times 2 is 1. Times 15 is 15 meters. Did you say 15 meters?
Yeah.
So how far did I go from here to there?
60 meters.
I went 60 meters in a positive direction, right? 60 meters in a positive direction. So let's find the area under here right now. What's this area?
Same thing.
You sure?
Yep.
Is this 2 seconds again?
Yep.
To get back to 0?
Yeah.
Yeah, it is? Okay, so I'm at 15 meters. So I'm just going to quickly draw this out just to show you what it looks like. So right now I went to here, that's 15. Then I did another 45, which took me up to here. And then another 15, which took me up to here. So I'm at 60 meters right now. That's kind of what happened, right? I went 15 meters away. I went another 45 at a constant speed, another 15. Well, here's how this looks. Okay? I'm going to go back to the original thing I talked about today. I start at the hospital. And I go from the hospital to Cartier Ford. How fast can I go? Go on to his driver's license. How fast can I go from hospital to Cartier Ford? What's maximum? 52 town. Okay, so let's start at the end of the hospital and go there. So what's the maximum I can go? 80. So I'm going 80 kilometers an hour for the first so many seconds. That covers that amount of distance, right? Then I hit my cruise control at Cartier Ford at 100 kilometers an hour, and I'm going to do that all the way until I get to Yorkton. Well, that's what this looks like. Constant speed for 100 kilometers an hour. Times it by 40 minutes that I travel at. How far did I go? I don't know, about 60 kilometers, right? So far I've gone a kilometer or 2 from hospital to Cartier. Then I go another 70 or so to get to the outskirts of Yorkton. Then I got to slow down. That's what that looks like. If I were to draw that out, that's what that looks like. But if this is the starting point at the hospital, I'm going to continue to get further and further away from myself, am I not? Until I then turn around and come back. Well, that's this part of the graph right here. What's this right here? How low does it go on that graph? Negative 15? So I'm negative 15 here. And how long does it go from here until I hit this point right here? What's that time?
2 seconds.
2 seconds?
Yeah.
So that's 2 seconds. So how far did I travel in here? Half times 2 times 15. Well, it's still what? It's 15, but it's negative. So what does the negative mean then? I'm starting to go back in the direction I came, right? So now I'm starting to work my way back over here. Okay? And when you figure this out, you're going to tell me whether or not I got all the way back. So you've got 5 minutes right now, and I want you to tell me how far I want my displacement from where I started in that question right now. With your partner, find that displacement from where I started. Okay? I've already calculated some of it for you. I want you to calculate the rest right now. Just do it on your own. Just do it on your own right now. You got a textbook. Do it on your own. Calculate your force. I want it back.
Because he wants to do all of it. Yeah, exactly, that's what I'm, yeah, 60, 65, this part. Yeah, so that's what I'm saying.